Have you ever just looked up at the night sky and, I mean, really looked and felt completely in awe, but also maybe a little bit lost? Well, you are not alone. Today, we are going to clear up some of that cosmic confusion and figure out what we're actually seeing up there. You know the feeling, right? You see this really bright light. Is that a star or is it a planet, like Jupiter? And then, whoosh, a flash of light streaks across the sky. Is that a shooting star? A meteor? An asteroid? What's the difference? These questions get all of us, and honestly, that's where the fun begins. But here's the good news. You really don't need a PhD in astrophysics to get a handle on this. The whole point here is to turn that, what am I looking at feeling, into, oh, I know what that is. So let's dive in and make some sense of it all. Okay, so first things first, why is it so easy to get all of this stuff mixed up? And I'll tell you right now, it is not your fault. The universe is just, well, it's a big, complicated, and frankly, kind of tricky place. I mean, think about it. From here on Earth, millions and millions of miles away, a star that's a raging inferno and a planet that's just reflecting light can both look like a tiny little dot. Then you have terms like meteor and asteroid that people use all the time as if they're the same thing. And here's the real kicker. Sometimes they are the same object, just at different points in its life. And when you try to wrap your head around the sheer scale of it all, yeah, it's no wonder it all gets a little jumbled. So to really start understanding what's what, we need to meet the main players. Let's do a quick who's who of the night sky. First up, the absolute powerhouse of the cosmos, the star. A star is basically a giant nuclear fusion reactor. It's this massive ball of super hot gas, just like our sun, that is literally making its own light and energy. Stars are the engines of the universe. A planet, on the other hand, is a completely different animal. A planet doesn't make any light of its own, not a single bit. It's a big object, sure, and it orbits a star, but the only reason we can see it is because it's acting like a giant mirror, reflecting the light from its nearest star back at us. Then we have the asteroid. You can think of asteroids as the leftover construction material from when the solar system was built. They're basically chunks of rock and metal, way smaller than planets, that are also orbiting the sun. Most of them are just hanging out in this big, crowded neighborhood between Mars and Jupiter we call the asteroid belt. You've seen those breathtaking photos from space, right? With those huge, colorful, swirling clouds? Well, that's a nebula. It's just a gigantic cloud of gas and dust floating out in space. And what's so incredible is that some of these are literally star nurseries. They're the places where brand new stars are being born. And finally, we get to the big one, the galaxy. This isn't just an object, it's an entire system, a gigantic city of stars. We're talking billions or even trillions of them, all held together by gravity. And get this, every single star you can see with your own eyes in the night sky is right here inside our home galaxy, the Milky Way. Okay, now that we know who's who, let's put them side by side. This is where we're going to clear up those really common mix-ups once and for all. So, star versus planet. It really all boils down to one single thing, light. A star makes light. A planet reflects light. That's it. One is a furnace, the other is a mirror. And that fundamental difference is why they look so different to us, even from so far away. And here's a super cool way you can see this for yourself. You know how stars seem to twinkle? Well, they're so incredibly far away that their light arrives as just a single tiny point. As that little point of light travels through our messy, shaky atmosphere, it gets bounced around, which makes it look like it's shimmering. But planets are much, much closer, so they don't look like a point. They look like a tiny, solid disk. And that little bit of surface area is enough to average out the wobbles from our atmosphere, so they shine with a steady, solid glow. And just in case you're wondering about the size difference, well, it's kind of hard to imagine. But try this. You could fit more than 1 million planets the size of Earth inside our star, the sun. That's how big the difference in scale really is. Okay, time to settle the great space rock debate. Meteoroid, meteor, meteorite. Here's the secret. It's not about 3 different objects, it's about 3 different stages of one object's journey. When that little rock is just minding its own business floating through space, it's a meteoroid. The second it hits our atmosphere and starts burning up, creating that amazing streak of light we call a shooting star, now it's a meteor. And if a piece is tough enough to survive that fiery fall and actually thumps down onto the ground, that piece you can pick up is a meteorite. Same rock, different zip codes. Now for our last comparison. Galaxy versus nebula. This one's easy because it's all about scale. A nebula isn't something that exists next to a galaxy. It's a tiny, tiny part of a galaxy. That's like comparing a single cloud to the entire planet Earth. They're not even in the same league. Let's just put some numbers to that, because it's pretty wild. A nebula might be busy creating, say, a few thousand new stars. A star cluster, which is another thing you find inside a galaxy, could have millions of stars. But the galaxy itself? You're talking hundreds of billions, sometimes even trillions of stars. The leap in scale is just staggering. So what does this all actually mean for you tonight when you step outside and look up? Well, let's turn all this theory into a super simple, practical guide. Now you can be a cosmic detective. When you're out there, look for that really bright light that's just steady. It's not twinkling. Boom, you're looking at a planet. See that quick, sudden flash that zips across the sky and disappears? You just saw a meteor. And hey, if you're ever in a really, really dark place, far from city lights, and you see this faint little fuzzy patch, you might just be looking at the Andromeda galaxy. And that light has been traveling for 2.5 million years to reach your eyes. How cool is that? And suddenly, it's not just a bunch of random dots anymore, is it? You're actually seeing a cosmic map. You're identifying planets. You're catching meteors. Maybe you're even spotting whole other galaxies. You're reading the sky. Every single point of light up there has a name, a category, a story. Now that you have the key, what are you going to discover next? Happy stargazing.